Hello students, today I am going to teach you a very important and interesting chapter, chapter 8, Introduction to Trigonometry. As you can see, you cannot imagine the world without trigonometry. Now, in this chapter, we are going to cover these topics. First one, Introduction. In this, I will make you able to understand the meaning of trigonometry and real life applications of trigonometry. In trigonometric ratios, we are going to discuss about 6 trigonometric ratios in detail. In the third one, trigonometric ratios of some specific angles 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. In the fourth one, we are going to discuss about trigonometric ratios of complementary angles. Complementary means the sum of two angles must be 90 degree. As you can see, when you will add 0 degree and 90 degree, you will get 90 degree only. When you will add 30 degree and 60 degree, you will get 90 degree only. And the last, we are going to discuss about trigonometric identities. Now, we will start with introduction. What does trigonometry actually mean? The word trigonometry is derived from 3 Greek words, tri, gon and metron. Here tri means what? 3. Gon means sides and metron means measure. Now, a 3-sided polygon is called a triangle. As you can see, 3 sides. So, the meaning itself is so simple. It is just the measure of all the things possible in a triangle. Now, we are going to study about real life applications of trigonometry. Trigonometry can be used to measure the height of a building or a mountain. As you can see, this is a building and we are making a right angle triangle over here. So, we can easily measure the height of a building. Similarly, we can measure the height of a mountain. Trigonometry is also used in creation of maps. Basically, architects use the concept of trigonometry to design the map. So, there are a lot of things around us where you can see the use of trigonometry. Now, let us recapitulate about right triangle. Now, what do you mean by a right triangle? A triangle in which one angle is equal to 90 degree is called a right angle triangle. As you can see, a triangle ACP where angle C is 90 degree. So, triangle ACB is a right angle triangle. Now, the side opposite to the right angle means what? Side AB. So, what is the side AB called? It is called the hypotenuse. Now, what about other two sides? Means the side BC and AC. Here, these two sides are called legs of a triangle, or you can say AC is the base and BC is the altitude. So, now this was with respect to angle C. Here, if I will consider angle A, means what does side BC called? This will be opposite to angle A, or we can say this is called a perpendicular, or You can also say BC is the altitude. What about side AC? AC is called the adjacent side. Adjacent means what? Side closest to angle A. So, this will be the base. Now, what about side AB? AB is always the longest side. So, it will be called an hypotenuse, and this is the side across from 90 degree. So, when you are considering this angle, this will become perpendicular, this will become base, and this is hypotenuse. Now, I will touch upon Pythagoras theorem. This is a very important theorem, and we will be using this theorem in this chapter for solving questions. Now, in a right angle triangle, see, right angle triangle, the square of the hypotenuse side, as you can see this triangle which is right angled at B. So, what will be the hypotenuse? AC is equal to the sum of the squares of the other two sides. Other two sides means what? If this is hypotenuse, other two sides will be AB and BC. So, according to the statement of Pythagoras theorem, we have AC square means hypotenuse square is equal to the sum of squares of other two sides, means AB square plus BC square. Now, let us discuss the trigonometric ratios. There are 6 trigonometric ratios. Now, let us consider a right angle triangle, triangle ABC means what? Angle B is 90 degree. Now, we are defining the 6 trigonometric ratios with respect to angle A. That means I am considering this angle. So, first of all, let us discuss the first 3 trigonometric ratios, which are sine of angle A, cosine of angle A, and tangent of angle A. In short, we usually write sine as sine, S-I-N, and cosine as cos, C-O-S, cos, and tangent as tan, T-A-N, tan. Now, how you will remember the definitions of these trigonometric functions? So, I am going to write down something, just see. So, ka toa. Here, S stands for sine. See the definition of sine. O stands for opposite sides. So, the side opposite to angle A. What is the side in this triangle opposite to angle A? This is BC. So, I have written BC in the numerator. Now, H stands for hypotenuse. See, hypotenuse. So, side opposite to angle A divided by hypotenuse. Now, what is hypotenuse over here? AC. Okay. So, sine of angle A means sine A is side opposite to angle A divided by hypotenuse. Now, side opposite to angle A is also called perpendicular, and hypotenuse is hypotenuse only. So, you can say it is also equal to perpendicular upon hypotenuse. Now comes to cosine of angle A, means cos A. For this, C stands for cos, A stands for adjacent side, and H stands for hypotenuse. So, adjacent sides to angle A is what? AB, which is also the base, and and AC is the hypotenuse. So, we can also write it as base upon hypotenuse. Now comes to tangent of angle A. Tangent means tan A. For this, just remember this. TOA means what? T stands for tan. O stands for what? Opposite side. As I already told you, side opposite to angle A is what? BC, which is also called perpendicular. Side adjacent to angle A. Here A stands for adjacent side. So, side adjacent to angle A is called base, which is AB. So, you can also write tan A as perpendicular upon base. Now, you can easily remember the definition of this sine, cosine and tangent function. Sine is what? Perpendicular upon hypotenuse. Cosine is what? Base upon hypotenuse, and tan is what? Perpendicular upon base. You have to just remember so, ka, toa, S means side, O means opposite side, H means hypotenuse. Here C stands for cos, E stands for adjacent side, S stands for hypotenuse. And in TOA, T stands for tan, O stands for opposite side and A stands for adjacent side. Now, I will tell you about the other three trigonometric ratios, which are basically the reciprocal of sine, cosine and tangent function. Now, what is cosecant of angle A called? We basically write in short as cosec A. Cosec A, which is reciprocal of sine function. Means what? Cosec A can be written as 1 upon sine A. As we have already learned in the previous slide that sine A is perpendicular upon hypotenuse. So, cosecant A will be hypotenuse upon perpendicular. As you can see, AC is the hypotenuse and BC is the perpendicular over here. So, cosecant A is reciprocal of sine function. Now, what about secant of angle A? We called it in short as sec A, which is reciprocal of cos function. Means this is basically 1 upon cos A. As you can see, the value of cos A is what? AB upon AC. AB is the base, AC is the hypotenuse. But secant A is reciprocal of cos A. So, we will write down AC upon AB means what? This is hypotenuse upon base. Now comes to cotangent of angle A, which we usually write as cot A. This is reciprocal of tan function, 1 upon tan A. Means what? Cotangent of angle A will be AB upon BC. AB is the base and BC is the perpendicular. So, cosecant, secant and cotangent are the reciprocal of sine, cos and tan respectively. Now, we can also define the value of tan as sine A upon cos A. How? See, tan A is what? BC upon AB. Now, if I will divide the numerator and denominator by the side AC, what will you get? BC upon AC, which is sine A, and in the denominator AB upon AC, which is cos A. So we can write tan A as sin A upon cos A. Now what about cot A? It is basically the reciprocal of tan A. So we can also write it as 1 upon tan A. Since the value of tan A is what? 1 upon sin A upon cos A. So this will give you cos A upon sin A. See this? So the value of cot function can be written as cos A upon sin A, or you can simply divide the numerator and denominator by AC. You will get AB upon AC, that is cos A, BC upon AC, which is sin A. So the trigonometric ratios of an acute angle in a right triangle, see, acute angle in a right triangle express the relationship between angles and the length of its sides. Now we are going to understand it better by an example. See example 1. We are given with tan A as 4 by 3 and we need to find out the value of the other trigonometric functions with respect to angle A. This is very important. You have to see with respect to which angle you need to find out the values. See, consider a right angle triangle ACB. Angle C is of 90 degree and angle A and angle B are acute angles. And in this question, we are given that we need to find the other trigonometric ratios with respect to angle A. So we have considered a right angle triangle ABC, which is right angle at C. Now we know that tan of A is 4 by 3. Now what will be 4 over here and what is 3 over here? Now 4 means, since it is perpendicular upon base, according to the definition of tangent function, tan A is perpendicular upon base. Perpendicular means side opposite to angle A, base means side adjacent to angle A. So I have considered the length of side AC as B, the length of side BC as A, and the length of side AB as C. So tan A will become A by B. Now I have to consider a positive number K. So I will get the value of A and B as 4K and 3K. I need to calculate the value of C. Since I know one angle, I know two sides, I have to calculate the value of C. How will you calculate the value of C? For this, we need to apply Pythagoras theorem. We need to apply Pythagoras theorem. Now what does Pythagoras theorem says? AB square means hypotenuse square is equal to BC square plus AC square. BC square plus AC square. Now AB is what? The length of measure of side AB is C. So this will become C square. BC square means the length of side of BC is A. So it will become A square plus there is a summation sign in between. So AC square, the length of side AC is what? B. So this will become B square. As you know the value of A and B. So simply substitute the values of A and B in this. What will you get? C square will remain as it is equal to A is what? 4K and B is what? 3K. So C square is equal to 4K whole square plus 3K whole square. When you open up this, what will you get? 16k square plus 9k square. Now since the variable is same, or you can say the number is same over here, so 16 plus 9 will give you 25 and k square will remain with it. Now since c square is equal to 25k square, how will you calculate the value of c? You will get c as 5k. As you know, c square is 25k square. So c will be square root of 25k square. You will get 5k. Now you have the value of a, b and c, and you know you have to calculate the trigonometric ratios with respect to angle A. So what will you get? As you know, sine A is what? Perpendicular upon hypotenuse. Here I have taken the measure of length of side of perpendicular as A and the length of measure of hypotenuse as C. But we have the value of A as 4k and we get the value of C as 5k. So you will cancel out k over here, you will get 4 upon 5. Now cos A. Cos A is what? Base upon hypotenuse. Base is what? B. H is what? C. And you know the value of B as 3k and the value of C as 5k. So 3k upon 5k. When you will cancel out k, you will get 3 by 5. For cot A, it is basically the reciprocal of tan A and the value of tan A was given as 4 by 3. So 1 upon tan A you will get 3 by 4. Now cosecant A, it is reciprocal of sine function. So you can see you are getting the value of sine A as 4 by 5. So cosecant of A will be 5 by 4, simply the reciprocal of sine function. Now secant A is reciprocal of what? Cos function. So 1 upon cos A will give you secant A. So you will get 5 upon 3, simply the reciprocal of cos function. Now let us understand another example in which we are given with a right angle triangle PQR and we need to find out the value of tan P minus cot R. So basically we are given with two sides of a triangle, we need to calculate the third one. So for this we have to apply Pythagoras theorem, which is PR square is equal to PQ square plus QR square. When you will substitute the values of PR and PQ, you will get the value of QR as 5 centimeter. Now as you know, tan P is what? QR upon PQ. QR is base and PQ is the perpendicular. So you will get tan P as 5 by 12. And cot R. Cot R is what? QR upon PQ. QR is base and PQ is the perpendicular. So what will you get? Cot R as 5 by 12. So we need to find out the value tan P minus cot R, which is 5 by 12 minus 5 by 12, you will get 0. Now I will discuss question 8 of exercise 8.1. We are given with 3 cot A is equal to 4 and we need to prove that 1 minus tan square A upon 1 plus tan square A is equal to cos square A minus sin square A or not. For that we need to just draw a right angle triangle ABC which is right angled at B. Now as you know, cot A is what? AB upon BC, which is given as 4 by 3. As I have already explained you that we need to consider a positive number. Here I have considered k is a positive number. So I will get the value of AB as 4k and the value of BC as 3k. Now for the third side, which is AC, we need to apply Pythagoras theorem. Simply substitute the values of AB and BC in this. you will get AC as 5K. Now, as you have the values of AB, BC and AC, you can substitute these values in the trigonometric ratios definitions, which is tan A, which is BC upon AB. So, you will get 3K upon 4K, just cancel it out, you will get 3 by 4. Similarly, sin A perpendicular upon hypotenuse, so BC upon AC, you will get 3 by 5. Cos A, you will get 4 by 5. Now, we need to compare the left hand side and right hand side to know whether they are equal or not. Since you are having the values of tan A, sin A and cos A with you, just simply substitute the values in the LHS. What will you get? 1 minus tan square A upon 1 plus tan square A. Now, tan A is what? 3 by 4. Simply substitute 3 by 4 over here. What will you get? 1 minus 9 upon 16 upon 1 plus 9 upon 16, which will give you 7 by 25 after solving this. In the right hand side, you have cos square A minus sin square A. Simply substitute the values of these functions in this. What will you get after solving? 7 by 25. So, are they equal? Yes. So, both LHS and RHS are equal in this. Now, let us take up the questions for your homework. Question number 1, if sin A is 3 by 4, you have to calculate the value of cos A and tan A. Question number 2, we are given with 15 cot A is equal to 8. You need to simply find out the value of sin A and secant A. In question number 3, you have to consider a right angle triangle, triangle ABC, which is right angled at B, and the value of tan function is given. Tan A is given 1 upon root 3. You need to calculate cos A into cosecant C minus sin A into sin C. And in second part, you need to find out sin A into cos C plus cos A into sin C. Now, let us quickly recapitulate what we have studied today. In a right angle triangle ABC, right angle at B, we have discussed about 6 trigonometric ratios. First one was sin A, which is perpendicular upon hypotenuse. Second one was cos A, which was base upon hypotenuse. And the third, tan A, which is perpendicular upon base. Now, other 3 trigonometric ratios are just the reciprocal of these 3 trigonometric ratios, cosecant A, secant A and cot A, which are respectively the reciprocal of sin A, secant A is reciprocal of cos A and cot A is reciprocal of tan A. Now, we have already studied that if one of the trigonometric ratio of an acute angle is known, you can easily calculate the other trigonometric ratios of the angle which is given. Hope you have understood today's session well. Thank you.